Hello class, welcome to Geometry Lesson 6.1, which is all about the Polygon Angle Sum theorems. By the end of this lesson, you should be able to find the sums of exterior angles and interior angles of polygons. So let's jump in with our first example where we want to explore the Polygon Interior Angle Sums. So remember, interior means inside, so we're talking about inside these shapes. And polygons we haven't really talked about a lot this year. So remember, polygons are any shape with any closed shape with straight sides. And if you hear the term regular polygon, that means that all of the side lengths and all of the angle measures are the same. You'll hear me use that periodically throughout the lesson. So if you don't remember that word, maybe jot that down in your notes as a reminder that regular means all of the side lengths are the same and all of the angle measures are the same. Okay, so jumping in, how does the number of sides of a convex polygon, n, relate to the sum of measures of its interior angles? So n is going to be what we use to represent the number of sides. That's always going to be the variable I use, okay? So you know that the sum of the interior angle measures of a triangle is 180. That's something that we've been working with for years, but we've really been using that this year in geometry. So what if we take all of these polygons with more than 3 sides and break them up into triangles? So if I have a quadrilateral, so something with 4 sides, I can break that 4-sided figure up into 2 different triangles. And if I know that a triangle has 180 degrees in it, if a quadrilateral has 2 triangles, I would do 180 times 2, right? So I know that a quadrilateral would have 360 degrees. Then, if a polygon has 5 sides, I could break it up into 3 different triangles. And so then I would do 180 times 3. And 180 times 3 would give me 540. So you can do that with any polygon. You can decompose it into multiple triangles. So the pictures continue. If there's 6 sides, it's 4 triangles. If there's 7 sides, it's 5 triangles. So notice 4 sides gave us 2 triangles, 5 sides gave us 3, 6 gave us 4, 7 gave us 5. So all of these numbers that I just circled are 2 units apart. So if there's n sides, I know I can cut it up into n minus 2 triangles. So that means that the interior angle of any polygon can be found, the sum could be found by saying 180 times n minus 2. I want you to use that idea that 180 times n minus 2 to solve this problem on your own. What is the interior angle sum for a convex octagon? Remember, octagon has 8 sides. Hopefully when you plugged 8 into this formula, you did 180 times 6 because you combined that 8 minus 2. And you ended up with 1080 degrees for the interior angle sum for a convex octagon. So here's just something that you can take a screenshot of. It's that theorem that that summarizes everything that I've talked about so far in this video. Okay, so you can add this to your screenshot collection. And then, so that gave us this theorem that I was just talking about, that gave us the sum. It's really important to remember that. That gave us the total number of degrees inside a polygon. So this corollary is going to, instead of giving us the sum, so all of those angle measures together, it's going to give us a single angle measure of a regular n-gon, so however many sides it has. So remember, regular means same side length and same angle measure. This corollary only works with regular polygons, okay? Only works with regular. The way that you can find the single angle measure is you take the sum of the angles on the inside, what we just worked with, and you divide it by the number of sides or the number of angles, right? Because the number of sides and number of angles is always the same. So take the sum, divide it by the number of sides, and that will give you a single angle measure. All right, let's kind of use that idea a little bit to work with a more kind of real life problem. Jenna is building a corner cabinet to fit in a rectangular room. Okay, so let's think about that. A corner cabinet to fit in a rectangular room. A rectangular room, its corners are going to be 90 degrees. So we need this cabinet to fit into a 90-degree corner. Rectangles have all 90-degree angles. Okay, so if she builds it with the angles shown, how can she determine whether the cabinet will fit? So we have, I'm going to draw this kind of pentagon shape that we have going on there. We have 1, 2, 3, 4, 5 sides. Okay, and I know that this is 90, this is 135, 135, and this is 90. And I want to know, is this going to fit in that corner? So I want to know, is this angle also 90? So the way I can figure that out is I have a 5-sided figure. That means that there's a grand total of, let's see, 180 times 5 minus 2, and that will give me 540 degrees. So I know that's how many degrees are on the inside of this shape. And then if I do 90 plus 135 plus 135 plus 90, I end up with 450 degrees. So when I subtract those two, I should figure out what the remaining angle measure is. So 540 minus 450 gives me 90 degrees. So that means that this is 90 degrees. So then we want to know, will this cabinet fit in the corner of a rectangular room? Yes, because it has a 90-degree corner to it. So you would say yes, because of the 90-degree corner. Okay, so now I want you to try something that's similar to that. It is a little different, but I want to see if you can figure it out. So question 2, again, you're going to apply the Polygon Interior Angle Sum theorem. And we have each angle of a regular n-gon, so we don't know how many sides, measures 172.8 degrees. How many sides does this n-gon have? So I'm going to give you a clue. You need to use the corollary to Theorem 6.1. That was a couple slides back that hopefully you took a screenshot of. The one that I said you can only use if you have a regular polygon. Okay, so if you go back, use the formula from that and see if you can solve this problem. Good luck. All right, so I'm going to talk through how you solve this problem because, like I said, it is a little different than the example I just did. So I used the corollary, and I said 180 times n minus 2, so the sum of the interior angles, divided by the number of sides, gives me an angle measure of 172.8. Then all I have to do is solve it. So I multiplied n over, so I had 180 times n minus 2 equals 172.8n. Then I distributed that 180 to the parentheses. So I said 180n minus 360 equals 172.8n. Then I added 360 to both sides. Then I subtracted 172.8n from both sides. And I was left with 7.2n equals 360. And when I divide both sides by 7.2n, I end up with n equals 50, which means that this n-gon is actually a 50gon. It has 50 sides. All right, so now we've talked a lot about the interior angles, but what do we know about exterior angles? So if I want to know what the sum of the exterior angle measures of a convex polygon are, let's look at this picture here. These would be exterior, right? They're on the outside of the figure. So if I look, this angle, angle 1, forms a linear pair with, let's say, the interior angle 1. This angle 2 forms a linear pair with the interior angle 2. So if you think about it, all of those exterior angles form linear pairs. They form those straight lines with their interior angle kind of like partner. And we know that straight lines have a degree of 180 degrees, or a measure of 180 degrees. So if we want to know how many degrees are on the outside of a polygon, we would take the sum of both the interior and exterior, so that's that 180. So I'd have 180 degrees here, I'd have them here, here. So 1, 2, 3, 4, and if I kept going, 5, 6, 7, and 8. So I would do 180 times 8. But that doesn't fully work because I just counted the interior as well. So I have to subtract the interior. And we know that the way that you find the sum of the interior angle measures is you do the 180 times n minus 2. So if I did that, I distribute 180, I would have 180n minus 180n plus 360. Those 180 n's would cancel, and I would be left with just 360. So that means that the sum of the exterior angle measures is 360 degrees. And you want to remember that because that is always going to be true no matter how many sides a polygon has. The sum of the exterior angle measures of any convex polygon is always going to be 360. So if I ever ask you what the sum of the exterior angle measures are, doesn't matter how many sides there are. There could be 1,000,000, there could be 3, there could be 5. It's always going to be 360 degrees. So you want to remember that. Make sure you write that down. You need to know that in order to solve any problems about exterior angle measures. So with that said, why don't you try to figure out what is the sum of exterior angle measures of a convex 17gon? Good luck. Hopefully you ended up with 360 degrees because my really annoying rant about remembering that all of the sum of any exterior angles on any polygon would be 360 degrees. I know I'm sometimes annoying, but I do that to try to, get it to stick in your head. So don't forget, the sum of exterior angle measures, 360 degrees. Doesn't matter how many sides the polygon has. All right. Here is the theorem just stating that information if you would like to take a screenshot and add it to your collection of screenshots. But now, let's talk about finding an exterior angle measure. Now this is different because we're not asking about the sum of the exterior angles. If I asked for the sum, you would just say 360. But now I'm going to ask, what is the measure of each exterior angle? This is where things get a little more complicated. So suppose angle 1 is congruent to angle 3, and the measure of angle 1 equals 3x. So I would know that this is 3x, this is 3x, and the measure of angle 2 is 2x. And then if I look at angle 4, that has to be 90, right? Because this is the linear pair. And then this is the linear pair, so angle 5 is also 90. So if I add all of my measures together, they're all of the exterior angles, right? So they have to equal 360. So I'm still going to use that to solve. It's just not my final answer. Then I'm going to start plugging things in. Well, I know that the measure of angle 1 plus the measure of angle 2, and then instead of writing the measure of angle 3, I'm going to rewrite the measure of angle 1 because I know it's 3x. And then I already know that angle 4 and angle 5 are both 90, so I replace it. So I have measure of angle 1 plus measure of angle 2 plus measure of angle 1 plus 90 equals 360. Then I know angle 1 and angle 3 are both going to be 3x, and angle 2 is 2x, and I know that 90 plus 90 is 180. So then I have 3x plus 2x plus 3x, that gives me 8x. If I subtract that 180 over, I end up with 8x equals 180. Divide both sides by 8, and I'm left with x equals 22.5. Do not stop there. The question is, what is the measure of each exterior angle? Please, please, please don't stop once you solve for x. I know some of you still have that ingrained in you that that is the final answer, but that is not the final answer. I want to know what each angle measure is. So I'm going to plug 22.5 in anywhere that there's an x. So if I look at the measure of angle 1, 3x, 3 times 22.5 gives me 67.5. So I know that the measure of angle 1 is 67.5, and measure of angle 3 is congruent to that, so I know measure of angle 3 is also 67.5. Measure of angle 2 equals 2x, so I'm going to say 2 times 22.5. That gives me 45. And then the final thing, you guys are going to be tempted to skip this part because you already started knowing what angle 4 and angle 5 are, but I still want you to list all of the measures of the exterior angles. So I expect if there's 5 angles, you need to have 5 angles written down in your answer. All right, so this is going to be really similar to what you just did. Remember, you're going to set up an equation. Remember, these are all exterior angles. They're not inside the shape. And you want to figure out what is the measure of angle 4. Good luck. Okay, so in order to solve this problem, we're supposing that angle 1, angle 3, angle 4, and angle 6 are all congruent. So that's 4 angles that are all congruent. And we know that one of them, so angle 3, equals the measure of angle 2 plus 30. So the way I wrote that is I said 4 times the measure of angle 2 plus 30. Then I needed to add in angle 2, and this was my angle 5. I replaced it with angle 2 because I know that 2 and 5 are congruent. So then I added all of those together and set them equal to 360. So then in the next step, you can see I distributed that 4. So I said 4 times the measure of angle 2 plus 120 plus, and then I can combine those two measure of angle 2's into 2 times the measure of angle 2 equals 360. So then I have like terms. This is almost like saying 4x plus 2x, but instead of having x, I've written measure of angle 2. So I have 6 times the measure of angle 2 plus 120 equals 360. Subtract 120 from both sides, and you have 6 times the measure of angle 2 equals 240. Divide both sides by 6, you have measure of angle 2 equals 40. That's great if you got that far, but that's not the final answer. So hopefully you realize that it was asking what is the measure of angle 4. So I have to plug this information in for the measure of angle 4. I know the measure of angle 4 equals the measure of angle 2 plus 30. Measure of angle 2 is 40, so I have 40 plus 30, or the measure of angle 4 equals 70. If you have questions about that, please be sure to reach out for help, and I'm more than happy to assist you. Let's look at example 5. This is our last one, I promise. I know this is kind of a long video after break here. Okay, so example 5, find the measures of interior angles. So what are the measures of the interior angles of the pentagon shown? So just because I've done these angle measures so often, I just know pentagons have 540 degrees. So chances are I'm going to be setting up an equation that's equal to that number. So I have one angle is, let's see, 90. Let's say that this is my angle 1, 2, 3, 4, and we'll say 5. So angle 1 is 90. Angle 2 is 6x minus 3. Angle 3 is 3x plus 4. Angle 4 is 7x minus 3. Angle 5 is 6x plus 12. And I know that all of those added together have to equal 540 degrees. Now I can go through and I can add all of my x's together. So 6x plus 3x gives me 9x. 9x plus 7x is 16x. 16x plus 6x gives me 22x. And then I have 90 minus 3 is 87. Plus 4 is 91. Minus 3 is, let's see, I was at 91. Minus 3, that would give me 88. 88 plus 12 would give me 100. And then that is equal to 540. So 22x plus 100 equals 540. Subtract 100 from both sides, and I'm left with 22x equals 440. Divide both sides by 22, and I get x equals 20. But I'm not done yet because I want to know what the measures of the interior angles of the pentagon are. So I'm going to take that 20 and I'm going to plug it in. So angle 1 is still just going to be 90 degrees. Angle 2, 6 times 20 is 120. 120 minus 3 is 117 degrees. Angle 3, 3 times 20 is 60. 60 plus 4 is 64 degrees. Angle 4, I have 7 times 20 is 140. Minus 3 is 137. And angle 5 is 6 times 20 is 120. Plus 12 is 132 degrees. So those are my 5 interior angles. Now it's your turn. We have the measure of each interior angle of a regular 100 is 3x plus 26.4. So what is the value of x? This is slightly different because in the last one, you had a picture and they were all different angles. But here we have a 100 gon. So you have to figure out what does each angle equal before you can solve for x. So you're going to use kind of that corollary again from earlier in the video. Good luck. Hopefully for this one you got x equals 50. The way you get that is you say 180 times 100 sides minus 2. That gives us 17,640. And if I divide that by 100, because there's 100 angles, I get 176.4 degrees for each angle. So if I say 3x plus 26.4 equals 176.4 and solve for x from there, I have 3x equals 150 or x equals 50. If you have questions about that, please don't hesitate to ask. Here's the last thing, concept summary. If you want to take a picture of this to add it to your collection, perfect. But please be sure to reach out for some help if you need assistance with anything, and I'd be more than happy to assist you. Have a fantastic day.